Welcome back to finding the distance between a point and a line, part C. Now that we've got the two equations, we can go on and calculate the distance that we're really interested in. We now have everything we need in order to find the location of point W, which is the intersection of these two lines. Now, a little background to just brush up. The intersection of those two lines is a single point whose xy coordinates, we don't know what they are yet, would satisfy or be a solution to both those equations at the same time. So that's the one point that will be a solution to both those equations, which means that at that one point, those values of y and values of x should be exactly the same. Well, if that's the case, I can solve this system, and if you don't remember, there's a number of different ways to solve systems of linear equations, and we've got some tutorials to back that up. But I think the simplest thing in this case is to realize that both this stuff here and this stuff here have to be equal to each other or have the same value y at that point. So that means I can use the principle of substitution to solve this, which means that I can substitute this expression here for this expression down here. So that gives me the equation 1/2 x minus 2 is equal to minus 2x plus 1. And here's where I'm going to step in and say, I got to that equation using substitution. The phrase, set them equal to each other, is a very dangerous one and can lead you down the wrong road very often. I'd rather you thought about the mathematical principle of substitution. So once we've substituted, let's solve for x. I'm going to start by clearing the fraction that's in here, and I do that by multiplying both sides by 2, a technique that you hopefully learned in Algebra 1. So 2 times 1/2, that gives me x minus 4 equals minus 4x plus 2. Now I start to combine, add 4x to both sides. Add 4 to both sides, solving for x by dividing by 5, I get 6/5. In order to get my value of y, I'm going to give myself a little bit of room through the wonders and magic of technology. Well, we know that x is equal to 6/5. So we just need to find our value of y. We can use either equation, and I'm going to use the second equation. Y is equal to negative 2 times, in this case, x is 6/5 plus 1. Of course, I can write a 1 as 5/5. So I end up with y being equal to negative 7/5. So, updating my figure. Now I've got the intersection of the two lines detailed out as the point W being 6/5 comma negative 7/5. And as we said earlier, you can use the distance formula to find the distance between point W and the point 3 comma negative 5. Calling the given point, point 1, and point W, point 2, we can substitute in where x2 is 6/5, comes from W, and x1 is a 3, coming from our given point, etc. Now, you could just plug this into your calculator and get an approximation, but we're going to work it through and get an exact result. So, our first simplification. Here I've given everything a common denominator, so I can combine my fractions. Next step, And now I just need to square and combine. Squaring gives me this, and combining results in the square root of 405 over 25. Since 405 is 81 times 5 over 25, I can simplify my radical, square root of 81 being 9, square root of 25 being a 5 in the denominator, leaving me 9 square roots of 5 over 5, and that, checking on my calculator, approximates out to being 4.025. We now have a value for the distance between the given point, 3 comma negative 5, and the given line, y equals 1/2 x minus 2. Now that we have a specific result, I'd like to sum up what we've done in general. We'd start by making sure we can determine the given line's equation and the coordinates of the given point. Sometimes that's very straightforward. Other times it might be buried inside a problem. But that's where we want to start. Once we have that information, we can move on and determine the slope of the line. Remember, we found the slope of the line through the given point that was perpendicular to the given line. That we use that concept that the two slopes are opposite reciprocals of each other. Once we've got that slope and we have the given point, we can use that to write the equation of this line that passes through the given point and is perpendicular to the given line. Quick recap. This allows us to find the equation of this line that's perpendicular to our given line. Then we went on to find the intersection of those two lines right here, which you should be able to do both graphically and algebraically. And then once we found the coordinates of that intersection point, we used the distance formula to actually calculate the distance between the given point and the given line. Thank you for taking the time to review this. It's at times seems like a lengthy process, but all those concepts are things that are important to your mathematical background.